Hi, in this video, we are covering solubility. How do you know if you look at a chemical formula if it's soluble in water or not? Well, first, what does it mean to be soluble? Soluble just simply means that it can dissolve in water. If something's insoluble, we say that that's not able to dissolve in water, or really teeny tiny amounts of it are able to dissolve in water. So this video is going to rely pretty heavily on this table here. And in my class, it's in your reference tables. I think it's table number 6. It's called Aqueous Solubility Guidelines. Sometimes you'll see these referred to as solubility rules, as the title of this table is. But let's kind of read what this is saying. It's kind of start in this first column here, and you're looking at an ionic substance or a salt that contains these different things. And so the idea is that what you want to do is you look at the chemical formula and you find its components within here. At least one of the components would be listed in here. And let's say you're looking at something that has a group 1 ion in it. Now they mean group 1 of the periodic table. So hydrogen, lithium, sodium, potassium, and so on. Anything that contains a group 1 ion is soluble. Now this column here is for exceptions. This would mean that it's soluble except when combined with, and for this top row, there are no exceptions. All of these things, all group 1 ion containing salts, all salts that contain ammonium, acetate, nitrate, chlorate, perchlorate, those are all soluble all the time. Now, what happens if there is something in the exception column? For example, group 17 ions, those are elements from group 17 in the periodic table. Let's say, for example, silver chloride. Well, chloride is a halide. It's a group 17 ion. And look, it says that chlorides are soluble unless it's combined with silver or mercury or lead. And if that exception is listed here, and if we're talking about AgCl, for example, we would be led to believe that it's soluble unless it's with silver. So that would reverse whatever is in this column. So AgCl would be insoluble. Now there are some situations when you get down here, these three here are insoluble, and the exceptions would reverse their insolubility to become soluble. But let me show you some examples with this, because that's maybe the best way to learn this. Here's one example, NaF. So the way you do this is you kind of look at, all right, we've got Na, that's the positive. So the positive in this is Na+. The negative in this is F-. So if I find the cation here, that's a group 1 ion. Sodium's in group 1. Well, these are soluble always. So I therefore can say this is soluble. But let's say you wanted to try to do it from this direction here, F-. F- is a group 17 ion. Those are always soluble too, unless they're combined with silver, mercury, or lead. Sodium's not any of those three, so that also would tell you it's soluble. You're never going to get conflicting reports if you find the positive listed one way, the negative listed another way. They're still both going to point you either toward soluble or insoluble, so you don't have to worry about that. Here's another example. This says silver acetate. Well, acetate is right here, and acetates are always soluble. No exceptions, even if it's with silver. No exceptions, always soluble, so silver acetate would be soluble too. Here's another example, PbCl2. Well, I'm not finding lead in here, so then I want to look by the negative. Chloride. Chloride's a group 17 ion. Those are soluble, unless they're with lead. Uh-oh, that would make this insoluble. So that's where this exception would come into play. If the exception is listed there and that's part of your substance, it flips whatever you have in this column. So from soluble in this case to insoluble. Here's another example. Strontium hydroxide, SrOH2. You're not going to find strontium on here, I don't think, but you will find hydroxide. There it is. Hydroxide is at the bottom. Hydroxides are insoluble unless they're with group 1 ions. Strontium's not in group 1. They're also insoluble unless they're with ammonium or calcium or barium or strontium is there. So what does that mean then? Well, that means instead of this being insoluble, it is soluble. It flips the solubility when the exception is part of that compound. Here's another example. Ca3PO42, also known as calcium phosphate. I don't see calcium in here. By the way, most of the negative ions are listed in here. So I have to find phosphate. Phosphate's here. So that means I'm in this row here. Phosphates are insoluble unless they're with group 1 ions. Calcium's not in group 1. Or ammonium. Calcium's not ammonium. So that means this is insoluble. Okay? Here's another one, CuCO3. Look for carbonates. Here's carbonate, actually same row we were just in. Carbonates are insoluble unless they're with group 1 ions or ammonium. Copper's not any of those. So CuCO3 is also insoluble. And that's it. Is it soluble? In the end, you're going to get an answer of yes or no. But the way you do that is by referencing that reference table there, table 6 in your reference tables. There are other ways to remember the solubility rules or guidelines. They're one and the same. But here's what I found. I found that this table actually does the best job for all of the common substances you'll come across in a typical chemistry class. That's it. Thanks.